Hello and welcome to Mr. Connally's Math. We've got lesson 8.1.1 part 2 today. 813 through 818 are the problems we'll be doing. Don't forget to like this video and subscribe to the channel to get information about future videos. Guidelines for using this video effectively are: watch and listen to the video. Sound should be on. Do not skip ahead. Do not just mindlessly copy the work. Pause the video when you need time to write or think. Put a question mark next to the problem you don't understand. Rewatch and listen to the video as needed. And ask questions in class or in the comments below. Question 813. Mrs. Ferguson, your school librarian, asks you to conduct a survey on how many books students read during the year. You get the following results. Use the data to create a histogram. Use a bin width of 10 books. Remember, if a value falls on the line, place it in the upper bin. Okay, so first thing we need to do is put them all in order from least to greatest. That's pretty much how we start out every data display. Okay, so we see we've got a minimum of 4, a maximum of 35, a median somewhere in the middle there of all those numbers. Okay, so to make a histogram, we're using a bin width of 10. So notice I'm using the graph paper like you have in your notebook. Okay, so one square will be 10, then 20, 30, 40, and give yourself about 7 or 8 to go up. And then for frequency, that'll just be how many goes in each bin. So for instance, 0 to 10, this is saying right here, our number x is going to be greater than or equal to 0 or less than 10. So if it's 10, it goes to the right in the upper bin as it's set up here in this directions. Okay, so we're looking for numbers between 10 or less than 10. So that would be right here, 4, 8, and 9. That would be our first bin. There's 3 numbers. We don't include 10 because 10 goes between 10 and 20. Okay, so that means these numbers go all the way to there. Wow, that's quite a different bin. So the first bin has 4, 8, and 9. That's 3. So we'll count up 1, 2, 3 squares. Go ahead and fill in those squares right there. 1, 2, 3, 4, 5, 6, and 7. Okay, and then for the next one, we've got 1, 2, 3, 4, 5, 6, 7 in the second bin. So we'll go all the way up to 7 for that one. Okay, and go ahead and shade in that for the second bin. Go ahead and continue to the rest of them on to here. Pause to finish that up. All right, ready? Let's go to the next. And then this one says, is the mean or median a better measure? So the mean or median a better measure of the center. Find the value of whichever is more appropriate. Okay, so think about what we did in class. Look in your notes. Which is better, the mean or the median in this case? Let's go ahead and decide based on that histogram. And it's a better measure because, so go ahead and give yourself a reason why you chose mean or median. Okay, and then that same answer will go here, and you'll need to actually compute it. So if you wanted the median, for instance, then you would find whatever number is in the middle, right? Count up all the numbers, find the middle one. The left side should have the same as the right. If there's 2 in the middle, then remember it's the average of the 2 numbers. You add them together and divide by 2. Okay? So, and then if you think the median, or if you think the mean is better, the average, then you'd have to add up all these numbers and divide by the number of numbers. So you'd add these all up, every single number. Take that number, divide it by how many numbers there are, and that would be the average, or the mean. Okay, so whatever you decide to do, you'll compute it there from all the numbers, whether you chose mean or median for these 2 answers. Okay, so go ahead and pause to finish that part. And let's move on to the next. Okay, part C, they want you to make a box plot of the data, and they want you to put it above the histogram. Remember in class we talked about combining the box plots and the histograms together to look at the distribution and the spread and shape of the data. All right, so first thing we got to do is put them in order from least to greatest. We've already done that. So now to make a box plot, we need the 5-number summary, which would be the minimum, which would be this number right here, the minimum. And the highest number would be the maximum, 35. So those numbers will go here and here. And then now we need to find the median, which would be exactly in the middle. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So that means our middle number is going to be between two numbers. All right, so that means 1, 2, 3, 4, 5, 6, 7, 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you've already computed the median from the last problem, you could obviously just write it in here. But our median is going to be in between 12 and 15. So that means you got to take 12, add it to 15, divide by 2. And that'll be this number right here. Okay, did I count that right? There's 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Okay, now, left side, we need to find the first quartile. The first quartile is going to be between 4 and 12. So find the middle number between those 8. There's 8 numbers. So that means 1, 2, 3, 4, 5, 6, 7, 8. The middle is going to be in between two numbers. It's going to be between 10 and 10 is Q1. So what number is between 10 and 10? That'll be the first quartile. And then on the right-hand side, 1, 2, 3, 4. This is going to be between 21 and 24. That number will go here for the third quartile. Okay, so now think of this number line like this. I'll get you started. Halfway would be about 5. So that means right here, just a little below halfway would be 4, right? So right here would be the minimum. And then we can draw a line across, and we're going to connect it to the first quartile, whatever that may be. So somewhere around here on 10. And then you got to continue making the box. 35 is the highest, that would be right here. So that'll connect there. So go ahead and finish the rest of your box up there. What it'll look like, where's the median, where's the third quartile. Find the interquartile range between them. That would be very helpful. Let me put that down here because you'll need it for the next question. Make sure you find the interquartile range. Remember, that's the length of the box between Q3 and Q1. It's Q3 minus Q1. Okay. Pause if you need more time. All right, next question. Describe the center, shape, spread, and outliers of the distribution. Okay, so let's start with the center. Which is closer to the center, the mean or median. And then the shape is double peaked, skewed, single peaked, symmetrical, uniform. Use 2 of those that best describes how you think the data looks. And the IQR is blank. I told you to find the IQR. If it's a high number, then it has high variability, because the higher it is, it means the more spread out it is. Okay, it also means if it's a lower number for the IQR, that means it has lower variability. Okay, and let's see. There are no outliers, or are there outliers? Look on the paper or look on the data numbers and decide, is there a number that sticks out that's not closer to the other ones? Is there a big gap between it? If there is, then say there are outliers and say which ones they are. Or if you decide there's no outliers, then just say there are no apparent outliers. Okay, pause to finish that one up. Let's go on to the next. Question 14. Let's do some diamond problems. Remember, the top number is the top part is going to be the product of the two numbers on the side, x and y. And then the bottom number is their sum. Okay, so basically that means for this part right here, we just need to take 1 1/5. Oops. and we want to multiply it by 3/4. So 1 1/5 times 3/4, we know that's going to be, we got to turn it into an improper or fraction greater than 1. 1 1/5 would be 5/5 plus 1/5 is 6/5. So this becomes 6/5 times 3/4. Okay, so multiply those together. That answer will go in here. And then this number right here will be the sum of those two numbers. So it will be 1 1/5 plus 3/4. Okay, so let's make this easier and just turn them into 6/5 plus 3/4. Okay, now we can just add them together. So common denominator of 20. So this will be times 5/5. And this will be times 4/4. So that would be 24/20 plus 15/20. Go ahead and add those together. You can leave it as an improper fraction, or you can make it a mixed number. It doesn't matter. That answer will go in here. All right, let's look at the next one. 2/5 is our first number, and then we don't know the second one, but we know their sum will equal 11/15. So that's like saying 2/5. 2/5. Actually, let's do that work down here. 2/5 plus y equals 11/15. So to get y by itself, that means we subtract 2/5. So that means y would equal 11/15 minus 2/5. Okay, so find a common denominator and find that answer, so you can put it in there. And then let's look at the top one. The top one is 2/5 times whatever number you have for y will equal that number. So this will be 2/5 times whatever number you got here, and that'll equal the number that goes here, the product of those two numbers. Okay, so it's a good thing we did that one first, finding out the y first. Okay, all right, pause to finish that part up. Let's go on to the next one. -4/7 and -1/2. So this is going to be the product of those two numbers, so -4/7 times -1/2. Go ahead and multiply those together. You get a positive number on top because a negative times a negative is a positive. Then 7 times 2 is 14. And that number will go in there. And then for the bottom, this is the sum of the two numbers. So -4/7 plus -1/2. Go ahead and find a common denominator of those two numbers, and then add them up, and that number will go inside this little part of the diamond. Okay, let's look at D. Same thing. We're going to take this is going to be 1/3 times -2/3. So 1 times -2 is -2, and 3 times 3 will go there. And that's the number that will go on the top box. And the bottom, go ahead and multiply those together to get your answer. I'm sorry, add, this is the sum. So -2/3 plus 1/3. It does have a common denominator of 3. So that should make that part easier to fill in that one. Okay, pause to finish that up. All right, let's go on. Question 15, solve the following equations using any method. Show your work and check your solution. Okay, so Question 5x plus 20 equals 3x plus 4. Let's look on the left side. Is there anything to simplify? No. Right side? Nope. Those are unlike terms. We can't combine them. So let's look at the x's. They both have at least 3 x's on each side. So let's take away 3x from both sides. So that leaves 2 x's on the left plus 20. These x's are gone on the right, but we do have 4 1's left. So 2x plus 20 equals 4. We want to get the x's by themselves, so let's get rid of 20 positives. So doing that, we'll cancel. We get 2x equals 4 minus 20. Whatever 4 minus 20 is, it would be a negative number. We know x will equal that number divided by 2. Okay, so 2 times the number equals the box, so x will equal the box divided by 2. We'll work backwards, use an inverse operation. Instead of multiplying by 2, we divide by 2. All right, substitute that number into here and simplify the left side and the right side. We want to know if they're equal. They should be. So when you're done simplifying, the left side should be the same number as the right side. It won't be the same as your answer, but it will be the same number on both the left and the right if you did it correctly. Okay, so make sure you've done that. All right, let's go to the next one. 7x minus 4 equals 3x. There's nothing on the left to simplify, nothing on the right. Let's go to our next legal move of taking away twins on both sides. So there's at least 3 x's that are twins on both sides. So let's take away the 3x. We've got 4x minus 4 equals, these are canceled, and there's 8 1's left over. We've got 4x minus 4 equals 8. Okay, we want to get x by itself. So we add 4 to make this equal to 0. So 4x equals 12. And then that means our answer will be the opposite of multiplying by 4, which means divide it by 4. And then go ahead and substitute that number back in. Make sure both sides are the same number. All right, pause to finish that up. Let's go to the next one. And for C, 2x plus 6 equals x minus 9. Okay, so remember, let's look on the left and right. Is there anything to simplify? Okay. So if there's nothing to simplify, then let's start looking at twins. They have everything the same on both sides. They have 2x, at least 1x on both sides. So we'll subtract 1x from both sides. Taking away those x's leaves you with just 9 negatives on the right and 1x plus 6 on the left. Go ahead and look at what the next step is. You need to both sides. And that should give you your answer for x. Take that answer, substitute it over into this one to check your work and to make sure that both sides should be equal. They should be the exact same. It should be true. All right, pause to finish that part. All right, next, Mariana and Felix were in science class and were using a test kit to measure the amount of calcium in milk. They measured the amount of calcium in 1 cup of milk 10 times and got a mean of 294.6 kilograms. Okay, let's circle those numbers. So 1 cup, 10 times, got a mean of 294.6. They looked up the amount of calcium that is typically in milk and found out it should be 290 grams per 1 cup. Percent error finds the difference between the actual value and the measured value and then compares that difference to the actual value as a percentage. Find the percent error of Mariana and Felix's measurement. Okay, so what it's saying is that percent error is the measured value minus the actual value divided by the actual value. Okay, so it's kind of like percent increase or decrease. And then when we get that answer, we multiply it by 100 to turn it into a percent. Okay, so that means to get the percent error, we need to take the measured value, which they measured at 294.6, and we need to subtract that from 290. And then we divide that by 290. Okay, that's going to give us a number divided by 290. Whatever that number is, it's going to be a decimal. If we're going to multiply it by 100, and that should give you the percent error. Okay, so the percent error is going to be the difference divided by 290 times that by 100. Okay, don't forget the percent sign in the answer. Pause to finish that part up. Let's go on to the next. If 5 songs can be downloaded for $6, what is the cost of 7 songs? Okay, so we're comparing two things, so you should be thinking of rates. We've got songs and dollars. Okay, typically money goes where? Yeah, typically money goes on the top. It's usually price per pound or price per song or price per gallon. So our cost or our price is going to be $6 for 5 songs. We want to know what's the cost of 7 songs. Okay. So we want that number up there. How much is it for 7 songs? If it's $6 for 5, then that's $12 for 10. It's $18 for 15 songs, but we want to go the other way. How do we get from 5 to 7? Okay, that's not super easy. So let's go the other way. Remember, this is a rate, but it's not a unit rate. It has to have a 1 in it. So how do we get this to equal 1? Let's think. How do we get from 5 to 1? We just divide by 5. Okay, so that means we do the same thing on the top. We'll divide that by 5. So 6 divided by 5, whatever that is, it's a decimal, goes there. And then we'll take that number and multiply it by 7 to get how much it costs for 7 songs. So go ahead and do that now. Take 6 divided by 5, multiply it by 7. Should give you how much it is for 7 songs. Okay, pause, finish that one up. Let's go to the next. Question 18. Roger has a bag of marbles. There's 6 red, 4 blue, 3 white, and 7 green. If he draws 1 marble, replaces it, notice this is replacement, we put it back, and then draws another, find the following probabilities, writes your answer as a fraction and a percent. Okay, so the the probability of red and then another red. Well, let's look. How many total marbles do we have? Okay. So go ahead and count up all those marbles, put them in there. That's going to be our denominator. So we want the probability, what's the probability of getting red and then another red? So that's the probability of red and red. So that'll be, since it's and, we're going to multiply. So the probability of red times the probability of red. So the probability of red in this case is going to be 1, 2, 3, 4, 5, 6. Out of how many marbles? You'll find that out. And then again, it's the probability of 6 over the total amount of marbles again. So go ahead and just multiply those together. You should get 36 over that number on the bottom. Okay, and then if you can, reduce it by 2 to both the top and the bottom, or 4, or whatever. If there is a common factor, then go ahead and simplify it. It also says to write it as a percent. So that means you'll take 36 out of this is the same as 36 divided by the denominator times, that turns it into a decimal, then times that by 100, and that'll give you the percent for that. Okay, so use your calculator to check. 36 divided by the denominator times 100 will give you the percent. Because remember, you need fraction and percent. Okay, so what's the probability of not white over how many green there are? Okay, so that's the probability of not white times the probability of green. Okay, so not white would be how many are not white. So there's 1, 2, 3, 4, 7, 13, 14, 15, 16, 17. 17 out of the total number of marbles times, so remember it's the total number of marbles again, and the probability of not 6, that's a G. That looks confusing. So green, so that would be 7. Go ahead and multiply 17 times 7. That's what, 70 plus 49, that's 119. Out of whatever the number of marble is times itself. $70 plus 49 is 119, yeah. Okay. And then you can simplify that if you want. To turn it into a percent, you just take 119, divide it by the denominator, multiply it by 100, and that'll give you your percent. Okay, pause if you need more time. Let's go on to the next. Roger has a bag of marbles. What's the probability of blue or white and then getting a red? Okay, so we've got probability of blue or white times the probability of getting red. Okay, so blue or white is going to be this amount, so that's 1, 2, 3, 4, 5, 6, 7 out of how many total marbles there are. And we're going to multiply that by the probability of red, which is 1, 2, 3, 4, 5, 6. And that gives us 42. And the box times the box will be down here. That's our probability as a fraction. Now to turn it into a percent, we take 42, divide it by the denominator, and then we multiply that answer by 100, and that'll equal the percent. Okay, for D, find the answer for part A above if Roger does not replace the marble. So we want the probability of red and then red again, assuming he doesn't put the marble back. He takes it out and then he just leaves it on the table. Okay, so that means the probability of red is going to change. The probability of red was 1, 2, 3, 4, 5, 6 out of the total number of marbles. And then we multiply that by how many reds are left. There's 5 reds left now because we took 1 out. So now there's 5 reds. We took 1 out. There's 5 reds. And then also, it's the total number of marbles minus 1. Because look, we took this red out. How many are left now is just these. So it's it's these numbers minus 1. Okay, so multiply those together. You get 30 over whatever that bottom number is. And then to make that into percent, you do 30 divided by the box, times it by 100, and that should equal your percent. Okay, so finish those ones up. Pause if you need more time. You're all done. Great job. Keep working hard. If you need anything, let me know. I'm here to help. Right now, I just want to tell you,
congratulations on completing your homework assignment. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math to get updates on future videos. Thanks for watching.
MrConnally.com